Excelente. Bienvenidos. Buenas tardes. Me llamo Kyle Winters. Vivo in Irvine, California. And today I want to talk to you about eBPF. Just a little bit more about myself. I've been in the security space for over a decade now. I've had various different roles at Cisco, whether it's technical consulting, technical marketing, developer advocacy. And today I'm a technical advocate as part of the learning and certifications team, taking a focus on security. So I want to talk to you all today a little bit about eBPF. We'll cover what is eBPF, and then we'll go into some actual practical examples. We'll take a look at tracing system calls as well as TCP connections using eBPF. And we'll also cover packet filtering using eBPF as well too. We'll close it out by talking about how eBPF and Hypershield, the new Cisco technology that'll be coming out soon, are related. And then we'll give you some resources as well to learn more about eBPF afterwards too. So to begin, what is eBPF? Before we go into what eBPF is, let's talk a little bit about the kernel space and what that is. And in a traditional architecture, most people are familiar with interacting with the user space. And that includes applications like web browsers, text editors, the applications that you're actually running, the Linux terminal itself. Everything that you're doing, that you're interacting with, typically is on the user space. Then there's also the physical hardware. That makes up its own space as well too, and that includes things like CPU, network cards, memory, storage, and all of this stuff is considered in the physical space. The applications that are in the user space need to be able to talk to these physical components. However, it's rather complex for any application to know exactly how to talk to all the different vendors of network cards and RAMs that exist out there. All these different vendors, there's so many different vendors on the physical hardware space, and there needs to be a normalized way for the user space to be able to communicate effectively with those. And that's where the kernel space comes in. It essentially sits in between the user space and the physical space and allows for a way to interpret system calls from applications and communicate that to the physical hardware. So it's essentially bridging that gap, normalizing it so in a way that it doesn't matter what type of physical hardware you have, that user space is going to be able to communicate with that physical space in an effective way. So what happens if you want to modify this kernel space? Well, it's typically not advised to modify kernel code on its own. It's very complex to do that. However, that's where eBPF comes in. So eBPF originated from the Berkeley Packet Filter. It got the name then Extended Berkeley Packet Filter, although now eBPF is just a term on its own. It no longer means Extended Berkeley Packet Filter because it can do so much more than packet filtering. It's a safe and efficient way to essentially extend the capabilities of the Linux kernel without requiring any changes to the kernel code itself. So you can make dynamic changes, loading and updating programs across your system without having to require a reboot. It allows you to iterate quickly and apply updates. There's performances advantages to it as well because it's not actually touching necessarily the physical hardware. It's got built-in security and safety checks on it as well too, leveraging these Linux eBPF modules. And there's a great and growing ecosystem of tools and pre-built functionality that you can leverage to extend your kernel functionality using eBPF. Now, let's go into a little bit of the basic concepts around eBPF. And the first is an eBPF hook. This is essentially a system call that occurs and triggers an eBPF function on the kernel. So some kind of process occurs on a Linux host or any kind of host it may be. And typically that call will trigger an eBPF program to run. That's considered the eBPF hook. Now, what happens then is there's also a concept of helper calls. So after that hook is called by the system process, Various different helper functions can be referenced as well, and these can do different things like searching, updating, or deleting key value pairs, being able to generate random numbers, collecting data and flagging metadata, being able to perform tasks with sockets like binding, retrieving cookies, redirecting packets, whatever it may be. And one data structure that's commonly used as well in eBPF is what is called eBPF maps. Consider this to be like a hash map with a key value pairing that lives in the kernel. So you can essentially write data to this eBPF map and be able to reference it in your Python code as well. And we'll give you some practical examples of how we do this when we dive into the live demo. There's a lot of different use cases that are available when it comes to eBPF. Just to go back a couple slides, you can see some of those use cases involve networking, observability, and security. But to take a little bit more of a focused approach on network security, with eBPF, you can do things like advanced packet filtering and processing, being able to inspect, filter, and manipulate packets at various different stages of its journey through the network stack. You can do DDoS mitigation as well, be able to identify when that happens and be able to quickly react to that, leveraging eBPF. You can also do things like intrusion detection and prevention, runtime security enforcement, data exfiltration prevention, application sandboxing. There's a huge list of use cases that are available. And we're going to cover some of them today, such as tracing system calls, as well as packet filtering. So in order for us to do that, we're going to leverage a tool called BPF Compiler Collection, also known as BCC. This is an open source tool that's available to all of you. It's great to use on Linux. It uses essentially eBPF technology to create all sorts of different capabilities around analysis, network traffic control, being able to trace system calls as well too inside of Linux. A lot of this is built in C. The actual eBPF modules themselves are built in the C programming language. But the nice thing about BCC is that it has a Python and Lua wrapper available for you. So you don't have to actually know how to write C code. You can leverage these libraries with Python and be able to perform these functions today. But one other honorable mention I want to make for another technology is Cilium. And Cilium takes a bit more of a network and security approach for containers and microservices. So you can do things like dynamic enforcement of network policies, deep visibility into network traffic. There's a ton of pre-built capabilities that are available to you from Cilium in their marketplace. I highly recommend you check that out as well. But for today's demo, we're going to cover BCC and use that as part of our learning. Everything that we're going to cover, by the way, in the demo today is available to you on Cisco U. That's u.cisco.com. We have free tutorials available that go through both of these examples that we're going to do. One of them is available today. The other one will be available in the next week. So it's free to sign up to take these tutorials. If you want to practice later on, you're more than welcome to take these tutorials as well. So let's just start by kind of dissecting the code that we're going to run a little bit. And we'll start with the tracing system calls leveraging eBPF. So here you can see I have a Python package, essentially a Python script. There's a couple components to it. The first are the modules that we're importing. You can see we're importing BPF from BCC. I think it's getting wild over there. We get importing those modules there. And right here is actually our BPF program. So you can see this is actually C code written into a string inside of Python. So this C code here is actually going to recognize, you can see where it says sys enter make directory. Anytime a new directory is created on this Linux host, we're going to recognize that. That's our eBPF hook. And we're going to call this helper function essentially to write this out to standard out. So you could eventually extrapolate on this further by doing things like logging and monitoring, leveraging this. But this is just an example that we're going to show you with system calls and how that eBPF can handle that. Here you can see this is actually where we're loading and running the eBPF program. So we're initiating that BPF object right about here. and we're passing the parameter, which is the text of our actual C code right up here. And then down below here, this is actually just a while loop that is running and tracking for any kind of event that comes in. So it's going to write the data out to our standard out. That way we can actually see it come into our terminal and know when that directory is created. I'll go through this demo here shortly, but I kind of want to save the demo for an end. Let me talk a little bit now about packet filtering with eBPF. So this is going to be another part of the demo as well. I have two Ubuntu servers. One is 192.168.9.130. That's going to be our source. And our target is going to be 192.168.9.131. We're going to try sending both pings and SSH connections from our source to our target. And it's going to work at first because we're not going to have the eBPF program running and loaded. But once we do load that, you're going to notice that those packets are going to get dropped, and there's not going to be any connection that's capable between those two hosts. The way that this eBPF program ultimately works is we're going to read in the packets that are coming in and essentially take out the IP header information and the TCP UDP header information from those packets. So we're going to pull out that information like the source IP address, as well as the destination IP address, the source port and the destination port, as well as the protocol that was used. Once we pull that out from the packet that comes in, we're going to look it up into an eBPF map. So we're going to have this data stored as to what our configuration is for the types of traffic that we want to block as an eBPF map. And when a packet comes in and we extract that IP and TCP UDP header, if it matches what exists in the eBPF map, then we're going to discard that traffic. So taking a look closer at the script that we're going to run itself, you can see this is actually just the C code. We start by importing libraries, and some of them, it's not just the BPF library, but also things for interfaces, the IP, TCP, and ICMP libraries as well. That way we can translate that into essentially our data structure that we want to leverage. Here's actually where we create that data structure. So you can see it has all of those components that we're trying to extract and take a look at. That source and destination IP, the source port and destination port, as well as those protocols. That data structure is ultimately what's going to be each entry, each index inside of that BPF map. Here's where we're actually initializing that eBPF map. So this is where we're taking that data structure and just saying that this is going to be our map that we're going to do, the key value pairings there. And the rest of this is actually the code that is going to, and it's a bit longer than this. If you want to see the full code, we'll have it on Cisco U in the next week. But this essentially is the code that is recognizing the packets that are coming in, comparing it to what is in the eBPF hash map, and if it matches a record that's found in there, it discards that traffic. Now, we have a Python script that we're going to run that handles a lot of this. Like I said, this script is going to be available to you all for free on u.cisco.com. But a couple pieces of information to discuss about it. The first is the interface name. So if you want to test this out on your own, make sure you put the correct interface name to match the IP address that you're looking for. That would go in the interface line there. And also the IP address of the source of the packets as well, too. So we'll go through and double check that in the live demo and make sure that that IP address is correct. So let's go ahead and jump into the live demo. I'm going to need a second here just to adjust my display so you can see everything perfectly. All righty. Everybody can see that. Good, good, good. So I have two terminal windows open here. They're both connected to my Ubuntu-2 host. And on this first one here, let's just go ahead and validate that eBPF is running properly. So we have this command, if I can find it, right here. more/boot, more boot config, and then it puts in the uname-r value there. And we're grepping for the word config_BPF. So if you run this command, and you see this line here that says config BPF equals Y, If you have that line and it equals Y, that means you have eBPF enabled on that particular host. So we know we have eBPF available on this host, which is a great starting point. Let's go ahead now and test out the system call functionality. So I'm going to go ahead and show you my Python script really quick here. Let's just open this one up. So you can see here's that script that I showed you earlier. There's our C code right up here where the BPF object is initiated, and then the while loop right there. So if we go ahead and run this, let's just say sudo python 3 eBPF system calls. All right, so now on this other terminal window, if I was to make a new directory, let's just call it test, you'll see instantly that gets picked up by eBPF. It recognized that hook, it triggered this eBPF module to run, and now we're printing to standard out that that new directory there was created. Now there's a lot of other cool stuff that you could do with BCC right out the box. Just to show you a quick example, if you were to come in here and ls user sbin and you just do bpfcc, you'll see there's a ton of capabilities that are included out the box with BCC. And conveniently enough, a lot of these are actually built in Python as well. So you can open up any one of these to understand how that function actually occurs. Just to show you an example, I'm going to go ahead and run one of these. It's going to be user sbin tcp connect bpfcc. So what this one's doing is it's essentially tracking any TCP connection that occurs on this host. So if I was to come over here and do a wget to google.com, you'll see that those TCP connections instantly show up and were picked up right there through the eBPF hook that occurred. So you can leverage these to essentially be able to track and log and monitor any of the system calls that are occurring on your Linux host. And if you see anything that's suspicious, you'll be able to track that more effectively now too. Now, let's go into our example about packet tracing. And I'm just going to exit out over here. So as you can see now, I'm on two separate Linux hosts. Ubuntu-1 is on the left and Ubuntu-2 is on the right. So let's go ahead and just test out our ping first. So if I was to ping 192.168.9.131, you can see we are successfully communicating. Our ICMP protocols working perfectly fine. We're able to communicate between those two hosts successfully. And just for the sake of it, let's go ahead and try that SSH connection as well. You can see it is initiating that SSH connection. I think I might have entered the password in wrong. And we're successfully able to SSH. Now, let's go back and let's take a look at our second eBPF package, which is the packet filtering one. And you can take a look here. Let me just scroll to the top. All that component, all the C code that I showed you earlier, that's all existing here in this string because we're going to import that as a string into our BPF when we initiate that BPF object. So it has all of that C functionality here. Here we have that interface name as well. You can see that right there. That is the interface that matches the IP address, and I can show you an example of that here shortly too, just to validate. But if we come take a look, that's the IP address as well of our source, the host on the left. So we can validate that here on the left, IP adder. You can see that there it is, 192.168.9.30. And if we come back over to this host, we can validate that interface as well as ENS 160. So as you saw, the pings and the SSH connections were successful, but we weren't running the eBPF program yet. So if I was to now do sudo python 3 eBPF packet filter.py, so this program is now running. When I try to ping this particular host from the source, the .130 host, you'll see those packets aren't even going through. There's nothing coming back. All those packets are being dropped. And if I was to stop this program, they would start coming in again. I'll go ahead and stop it just for fun. Just like that, they start coming back in. And then I run this again. And then they stop. That SSH connection that I was successfully able to make before, if I try that again, it won't even create that connection. There's no ACK coming back. It's just discarding that packet essentially. So this is a way essentially to do packet filtering, leveraging eBPF, and you can extend this capability a lot further as well too if you're interested. This is just a little sample to get you started, but hopefully it gets you excited about eBPF as well. And if I was to stop this program, by the way, just to show you, SSH is working again. I can SSH back into that host now, no problem. So this is one of the cool things one of the many actually cool things that you can do with eBPF. There's a lot of stuff that's available to you on this technology. Let me go ahead and switch back really quick to sharing my slides. So you may be wondering, why is Cisco teaching us about eBPF? That's a question I've heard before. There's a good reason why. eBPF has a strong relationship with Cisco Hypershield. If you're not familiar with what Cisco Hypershield is, it's a relatively new technology that's going to be coming out to allow an AI-driven data center. This is going to be built on top of eBPF. So all of the capabilities that Hypershield can perform across the network are going to be leveraging eBPF to perform those capabilities. It's going to allow you to scale leveraging AI, and this AI can do a lot of things, including assisting with policy changes, augmenting things for security teams, whether it's configurations, giving recommendations, and automating your security enforcement and the processes across as well too. So all of this is going to be leveraging eBPF across the data center to perform these capabilities. And while we wait for Hypershield to become available, we want to educate you on the foundational technology of it, which is eBPF. So definitely, get yourself more familiar with eBPF, because Hypershield is going to ideally revolutionize the data center and bring AI into it at a highly distributed scale. So hopefully this was some valuable information for you all. Hopefully you learned a couple of interesting things here. I highly recommend, if you're interested in learning more about eBPF, you can go to ebpf.io, as well as Cisco U. Like I mentioned, we have some tutorials available for you there. One that's available today is an introduction to eBPF, where we actually cover hands-on that system call tracing. We have another one coming out in the next week that is that packet filtering. So you'll be able to actually play with those Python scripts yourself and follow through those exercises. Cisco U is free and available to you. These tutorials are. There is premium content on there as well, but the tutorials, especially around eBPF, those are all free and available for you now. I also highly recommend you check out isovalent.com. They have some eBPF labs available for you on there, as well as some additional reading. They're a company that Cisco recently acquired and were a major key part of the founding of eBPF as well too. If you're not familiar with Cisco U, by the way, just to quickly fill you in on it, you can learn more from my friend Rigo over here. But it's just a one-stop learning platform that has a lot of different pieces of learning content, whether it's related to enterprise, security, collaboration, DevNet. We have full learning paths for certifications as well. So if you're planning on taking any of the certifications that you see on the board there, we have a ton of learning content with hands-on labs that you can take there as well too. While you're here, I'd highly recommend checking out the last Cisco session that we have with my colleague Hank over here in the Cisco U Theater. And feel free to book some time to meet the engineers, speak with Rigo over here, learn more about Cisco U, do the capture the flag sessions. And lastly, if you get a chance to fill out the survey, I know this, from what I understand, this link isn't working. So I'm not, you can go ahead and try it. People have had issues with it earlier. If it doesn't work, you can give me your feedback directly to me as well too. I'm more than happy to hear that. But before we go, I do have a giveaway. I have here a Cisco U pickleball set. Now, I believe one of you, and it might not be under somebody who's sitting under it right now, but if you can find this little heart thing here under your seat or under the seat next to you possibly, you will win this Cisco U pickleball set. And we have a winner. Just try not to play pickleball inside. You got to come to me now. That's a little feedback. Yeah, we got to take that back. Sorry. Yeah, but I definitely enjoy it and enjoy the rest of your sessions. We have one more giveaway as well.